When we design large storage devices, we need ways to quickly and easily retrieve information from specific locations in the storage devices. We create this retrieval system by storing information in chunks of bits that are stored at addresses, and we encode the details of these addresses within a binary code. So, we need a circuit that decodes these binary codes and activates one memory address at a time. This circuit is called a binary decoder. Imagine with me that we need to manipulate a memory device that has 8 memory addresses. To uniquely encode each address, we need 3 address bits. To make the addressing simple, we use unsigned binary numbers as our code for the addresses. Now what we want to create is a decoder circuit that will send a high voltage out on one line at a time so that exactly one address is activated at a time. So our binary decoder will have inputs and 2 to the n outputs. To create each of these outputs, we will need to implement every minterm. So we will need every variable and its complement. Then we will AND these literals together to create each minterm. For example, for minterm zeros, we will implement every complemented variable into the AND gate. We will similarly design every other minterm. We call this circuit a binary decoder because it decodes a binary input into a series of 1s and 0s on a set of data outputs. The first number in the name tells us about the number of bits in the binary code, and the second number in the name tells us about the number of data lines that are decoded. Because each data line corresponds to a different minterm, only one of the data lines will be 1 at any time. Once we have designed a binary decoder, we abstract its content and represent it with a box that receives a binary code and outputs a set of data outputs that correspond to the different minterms. Generally, each binary decoder will have n inputs and 2 to the n outputs. In some applications, we also add an enable input bit to the decoder. When the enable bit is 1, the decoder behaves in the way that we described earlier. When the enable bit is 0, all of the decoder outputs output 0. As you can see in the ROM implementation lecture, the binary decoder plays an integral role in addressing the different memory addresses in the ROM. You will also learn about how we use binary decoders to address memory locations in RAM.